All right, so we're going to start. My name is Leon. This is Marija. We've been working on NEAR for like 2 weeks now. We've been researching it, and today's presentation should hopefully let you guys know more about NEAR and how you can develop stuff on it, and like a general outline of NEAR. All right, so I'll start with the intro, and then Marija will do the demo in the end. So the first thing, it was so NEAR was founded by two Ukrainian/Russian guys. Alexander and Ilya. Oh, this is really complicated because I don't have a clicker. I have to come to the screen all the time. Right. Okay, so NEAR is a L1 blockchain, like Ethereum, like Solana, like everything. They work mainly in Rust, but they also have WebAssembly and JavaScript lately. So development, exactly. Mainnet launched in April 2020, so like 2 years ago, a bit more than 2 years ago. Since then, they have about 800 projects deployed on the NEAR ecosystem, as well as an EVM that they have for Aurora. They have about $500 million of funding. And yeah, they have Aurora, right? So it's essentially an L2 on top of NEAR that works exactly as an L2 for EVM, right? So it's a scaling solution for Ethereum, essentially. Right, so this is, in short, a part of NEAR's ecosystem. So they have the Explorer, of course. They have the Rainbow Bridge. That's the official bridge to NEAR and to Aurora as well. They have Ref Finance. It's a go-to DeFi place, I guess, on NEAR. It has swaps. It has one sec. So it has swaps. It has staking, has farming, etc. It has Aurora as well, like I mentioned. So it's an EVM. You can deploy Solidity code on it. You have the graph, of course, it's compatible with Aurora because it's EVM. And you have the Octopus network. It's a bit of an interesting thing. So it's basically like an interoperability network for NEAR. So it's like Polkadot on NEAR, kind of. I might be wrong a little bit because I haven't researched it that much, but mainly it is something like that. You can check out everything else. Like there's this link, awesomenear.com. They have the list of all the projects, and if you have some, you can submit as well. All right. So what's interesting about NEAR? So NEAR is a proof of stake sharded blockchain. What does that mean? That's a good question. Nobody asked it, but it was a rhetorical one. So their proof of stake algorithm is called Nightshade, and I want to explain a little bit about what shading in general is. So essentially just imagine the EVM, and the EVM has a state, right? So every validator, okay, right now it's a miner, but in hopefully 10 days or more will be validators. And every validator downloads the whole Ethereum network, right? So it downloads the whole state. It's like, I think a terabyte right now. And every machine has the same state. So what NEAR is doing is they're actually sharding the state. So what does sharding actually mean? So sharding means essentially splitting up the state into different pieces, shards, right? And the thing is that, so essentially you have, for example, imagine you have 100 gigabytes, you have 10 shards, you have essentially 10 pieces that have each 10 gigabytes, right? And then you have validators, just like in Ethereum. And then to essentially keep the network safe, no validator works essentially on the same shard all the time. So they rotate. So for example, if you have 1,000 validators, if a number of them are malicious, you have to rotate. So you basically pick a random set of validators and put them onto one shard. And then it changes every epoch, which is a couple of days. So it's a period of time, right? And then there's this thing, which is really interesting, but NEAR actually introduces into the area, I guess. The interesting thing, like how it differentiates itself from Ethereum, is that it has this thing, it's called cross-shard transactions. So you have essentially, imagine just two states. For example, my account is stored, like everything I have, like my money, my account, my data on the blockchain stored in one shard, and then Marija's is stored in some other shard. And if I want to send money to her, my transaction actually has to affect two different shards. It's two different pieces of state, right? In different shards. And what happens is that you actually have to have this thing that's called cross-shard transactions. And it's a new concept, essentially, that NEAR is introducing. Essentially, when I do a transaction and it involves a different shard, changing a state in different shards, my transaction actually creates a different transaction that is processed a little bit later. So it basically has, they're called receipts, essentially. So it's a new concept, right? I've linked to the white paper and to the essentially the nightshade is right the algorithm, but there's a separate paper for the nightshade itself, and there it explains all the stuff related to the receipts and the cross-chart transactions. And essentially, what happens as well is that, for example, sometimes when you call different contracts, like if you want the contract to call another contract, in Ethereum it's pretty simple because you can just call it just like in, for example, you call some object in Java or somewhere else, right? It's relatively simple. But for Near, you have to have a cross-contract transaction, which is a specific concept as well. It's similar to the cross-shard transactions in the sense that a contract may be residing in some other shard, right? So you have to have the communication between shards, and for that they have this right. So cross-shard transactions, and they have promises between shards. So essentially, one transaction is sent on one shard, it calls the other shard, and then there's a promise in the first shard, it's waiting for the response, etc., etc. It's an interesting thing. It's kind of different from Ethereum. It's kind of well, it's refreshing in a sense. And yeah, I mean, that's something about Near for me. I think Maria's part is next. Yep. Right.
Yes, we have basically two standards for creating tokens, that fungible tokens. That standard on Ethereum is ERC20, and what is different than Ethereum is that here in Near we have all our fungible token contract holds in one map all account with their balance. So basically, when we create the new token, we need to pay some storage for me to send that token and for one who wants to receive that token. Second standard is fungible token metadata standard. This basically proposed to have some light to save some basic metadata about the token and to be faster to get the information about the token. There we have a name, the fungible token specifications version, I mean, then a number of decimals that what we and symbol that we need to have, we must have, and what is good to have is some icon or logo. And now I will go through to the code and show you how to create new token, how to use this token. First, what we need to start, we need to create a Near account. That's very easy. We just go to Near wallet. Testnet, I have already account, but it's pretty simple. Just create new account and you will get some test amount of Near. And the UI is pretty nice. It's simple. What next? We need to start the development of Near. We need Near CLI to install that. Just 10 p.m. install Near CLI. Also, I will go through the Near Explorer, Near Stats to see all the methods that we have in our contract. And now I'll start with demo.
Can I just interrupt for 1 sec? So one of the things that also Near introduces is like they're really putting the focus on bringing normal people, bringing people who are not into Web3 into Web3. And one of the things that they've done is instead of having like accounts that are essentially like hashes, right? So like your address is a hash. It's what 64 hexadecimals. They have human readable names. So essentially my account is never some hash, it's leon.near. And the same thing is with contracts. So they have names essentially. So that's an interesting thing. And like one of the things that I've noticed also about the wallet itself is the fact that, for example, when you create your wallet, you don't have to have a seed phrase immediately. Like the initial thing, you just get it to your email if you want. And like you can keep it that way if you want. Of course, it's less secure. But then if you choose to, you can switch to seed phrase and then et cetera, et cetera. Okay, go ahead.
Yes, the contracts in Near are write in Rust. You can write also that in assembly JavaScript, but we choose Rust as it's the main language. What is necessary is we use this near bind again. This is that you need to declare this macro because it will make your near contract valid on a near network. They help you to serialize, deserialize, to basically use the near network. And then we have you define one structure contract that will have some data inside what you want to save. Here we save token and metadata about our token. Also, then we implement that contract, and what you need to have is to initialize the contract. There is two ways to initialize the contract. First is that you can implement default from near bind again, or you can make your own new functions for initializations. We choose here to have our own new functions. Then what is defined is there is inside near contract standards. You can also use some macro to have all the functions already defined, like transfer, total supply, balance. But if you want to override some of these functions, you can do that. And we do this here in function transfer call, because function transfer call actually do the transfer and enable us in one transaction to have transfer and to use the method, to call method on some other contract. And that is all happening in one transactions. And here is the part that Lav mentions about cross-sharding communication. This is this piece of code where actually we communicate with some other contract that's cross communications contract. Also in external part, we need to write we make one trait where we write all the methods, like it's trait is interface, basically, where we write all the methods from the contract which we want to call from this contract. So here we will call a function on a transfer from cross communications contract. So actually we make now the external call. Receiver ID is the address of our contract, and function on transfer is defined on cross communications contract or other contract where we do some other stuff.
Can I just jump in one more time? So what happened with NEAR is that essentially how does, it's a bit different on NEAR regarding the fungible tokens like the ERC20. So right now how it works on Ethereum is you have the ERC20 contract, right, which has transfer functions, but also before that you have to have an allowance, right? For example, if you use Uniswap or anything, you need to allow Uniswap to use your tokens and then do the swap for Uniswap, exactly. So it's two transactions, right? So you have this allowance system. You're allowing another contract to use your own money. On NEAR, you have this fungible token on transfer or transfer call functions. What it actually does is just eliminates the allowance part, and essentially you're calling a function, which is some random function, doesn't have to be something specific, it's just a coupling function on a contract, and you're attaching fungible tokens to it. So essentially just imagine, just like you're attaching value to it, like you're attaching NEAR, like the native token, like if you're attaching value on Ethereum, you can attach any fungible token to a method call, which is pretty interesting. And then how it works is when you do that, you actually specify the method name you want to call in the other contract, and then there's a function that says essentially it's a listener. So like you have a function that's listening to transfer call, which is the function that you give. So you give the tokens and you give the call, and then it reacts on the other side. So it's an interesting approach. It's a bit different.
Yes, and then we get the callback here inside the first contract to write that. To build the project, you need to build the WebAssembly file, and that's the file that you will deploy. You can choose two ways to deploy. First is near deploy functions, but that will deploy to your account that, for example, for me, this is Marija testnet account, and I will need to, for one account, we have only one contract. So it's a good option if you want to deploy something on testnet, to choose dev deploy, and then you will this will create you new development accounts with new contract where you deploy your contract. So just npm run deploy, and it will build us our WebAssembly file, and it will automatically deploy our contract. We will get the address.
So which
Can you
Yeah.
choose the shard you're deploying on?
I don't think so, no.
No.
No, because it's they're using a VRF to pick shards within everything, so I don't think so. But the interesting thing, what you were wondering, like how you do this, is like when you deploy something on Ethereum, you have your own account with which you deploy a different account. Essentially, you get a different address. So when you deploy with your account near, like the contract gets attached to your account, and that's why you can only have one. So, which is it's a bit dumb in my opinion, but every time you need to deploy a contract, like for example, Main, you have to actually create a new wallet for it and then deploy it for that wallet. So that's just one. But also you can like have subdomains if you want, so that works, I guess. Yeah. Right, so like what Maria said, you have just near deploy. So near has a CLI tool, which is pretty good. It's decent. You can do a bunch of stuff from it. You can call transactions, you can call functions, you can read stuff. And then essentially you can use near login to just log in through the web browser. If you're logged in on the web browser, you can log into the CLI. And then if you just do near deploy, it's going to deploy it through the account you're logged into. But if you do near dev deploy, it's going to generate a dev account and then deploy it to that. That's probably a bit easier.
This is the process of near login. You are logged in, please. This is basically near Explorer. We got the transactions, but it's a little bit
It's a little
late,
slow.
so it's slow. We'll move to create a new
Can
token.
you just zoom in a little bit on the CLI?
Mhm. So to call, just find the address of our contract. Wait.
But we've been trying to make a.
Yes,
So we've
here
been trying
is.
to make a. Okay, is it done?
Trying to find, this is the Explorer, and this is our address that's created for us, where is deployed our contract. So
Right, so I don't know how well you can see actually, but so it's like, so it's near
near call,
call is just right, so it's a send transaction essentially on Ethereum, and then you
Yeah.
have near view as well if you're just viewing the state.
but if you have some cross sharding communication, that will need call
Yeah.
to pay transactions, then you write the contract address and the functions from your contract. This will be new. First, we need to initialize our contract, so it will be new. Just a second, again, new. Yes. Then we need first to initialize our contract, I mean to create fungible tokens, owner ID, I'll put me, total supply, some metadata, what I mentioned, we need to have a fungible token version, name of our token, example token, 3327, symbol, example token, 3327, number of decimals, and account ID is the signer of these functions. This, as you see, schedule basically the call for creating token, and again,
You're gonna
we
have to
will,
wait a little more.
yes, but we will move. Now, what I can do, I can, for example, transfer this token to Lav. I will use transfer function.
Is it worth any money?
No,
You really don't know. Then I don't really have to do it.
again, near call address or contract. That's what the transfer is, simple transfer money to Leon, some amount of money, and I'm the signer, but this yes, this failed because Leon is not registered to accept our money, but I can pay for him to he register and to use this.
Sure, so it's kind of weird because so on Ethereum, you have you're paying gas in your transaction to do whatever on the mainnet. And essentially you just do it once, right? So you just do it through your transfer that you're calling send, you're just calling a simple transfer on ERC20. You're paying the gas upfront, essentially. And how Neo works is for each, let's say, byte that you store on the contract, you have to pay a certain amount, and it's a storage. It's called a storage staking. It's called storage staking, and essentially, if you don't do it in advance, you can't actually use the contract. So if you want to store any data in a contract, you have to give it some money first, and then you can call a function. It's different than Ethereum.
Also, now the transactions pass and Leon has this example of tokens.
Okay.
Also, he can unregister himself from receiving this token, but if he has some money, this token that will be burned forever.
Can you do the like? Can you just view my balance?
Yes, I can view your balance. That's this balance up. Just to change the contract. Balance account ID. This is view functions. I can view the. He
Right.
has this money. What is for development good is this stat gallery, where you can see overview of your contract. Here you can see the functions that you have.
So it's like a separate thing, like just like on Etherscan, you have the tab where you can see the contract if it's verified. Here, you don't have to verify anything, which is kind of weird. And we still haven't figured out how you actually like, because so they don't have an ABI, they just have a JSON for everything. And essentially, like you can't view the contract that's deployed on the Explorer yet, hopefully. But you go to this website, which somebody made somehow, we don't know how, it's called stats.gallery, and it's for Near only. You just put your address there, and then it's gonna list a bunch of stats about it. And then as well, it's gonna list the available functions. Again, somehow, I don't know how, like how they fetch it or whatever, but maybe that's an interesting thing that maybe we can build that. Maybe we can build their ether scan for verification or whatever.
So here also the transactions you can see, and this is, for example, some
Zoom in.
transactions from.
Zoom in a little bit.
Mhm. This is some transactions. Mhm. On near Explorer, what you see is what method is called, on which contract, arguments, then you got received. This is event, how it's emitted in near also.
And the interesting thing,
Yeah.
like, so you saw it was a transfer call. It wasn't the same function that Marija called just now, but it was a different function. This is a different receipt. You essentially get a receipt, and if the function needs to access a different shard, it creates a receipt transaction. That's how it's called. And then it calls the right. So you see, like here, you have one receipt, and there's one ID. It starts with 3FHB, whatever, and then it goes down, and then it creates another one. And then, so this is essentially just like a separate transaction. And then sometimes it happens to see there's 3, 4, 5, sometimes, it just goes on.
Here we have these callback functions also. So
Yeah.
because of that also we have this
Linear
too many
receipts.
receipts. That's it basically about development on
Yeah,
near.
so I think that essentially, like, we've went through this process, and then the documentation is all right, but there's some missing stuff. And we've struggled to find more info about this cross-sharding stuff. We actually have some context from near Ukraine. We're gonna ask them probably about the cross-sharding a little more, and then essentially it's the development experience. How is it? How do you feel about it?
It's easy, as you said, it's easy to get if you are from Web2 to enter in Web3, that's easy to get in. What you need is to learn Rust, but UI is pretty nice. I mean, creating wallet is simple, interacting with wallet is very simple. You have a near CLI that you can use to view and call the function.
And like for example, for me, because I don't know Rust, and I've just gotten into Rust a little bit. It's an interesting thing because, for example, when you're learning Solidity, it's made specifically for Ethereum, and everything that is in Solidity is for Ethereum, or EVM rather. But Rust is a programming language that's made for everything else, right? For everything essentially. And it's just weird when you're going from Solidity to Rust, because it's like you're trying to figure out what exactly fits and how exactly they're including everything for the blockchain into Rust. So that's it's a bit I don't know how to say it, but like it's a different experience. You have to pick out a lot of stuff. Essentially, like comparing to Solidity, I think Solidity is much easier to just learn because it's just you're in this box of EVM, and Rust is different. As well, I mean, they have so they have WebAssembly and JavaScript as well, and it's the same thing.
Yes, and it functions in contract. For example, you have this macro payable public private, and also if your function will mutate state, you will need this as first parameter mutate self, and if it's view function, just self, it's enough. That's the way how you define.
Right.
And these are other parameters that accept.
Okay. Is that it?
Yes.
Okay, cool. Thank you for listening. Anybody have any questions?
Actually, those receipts are those promises, or are they finalized before the function ends? So basically, is the function over when the call is done, or are you waiting for other shard to respond?
Right, I think you're waiting because you have a callback, right? So you have so you send a transaction and you have a callback on the promise essentially. And they have promises essentially.
So you have to wait for the shard.
Right. And that's the thing we haven't still figured out because so like in the white paper, the receipts thing, they're mentioning like, okay, so you have receipts and receipts actually creating another transaction. And what happens is it hopefully, literally what they say is the next transaction will hopefully be included in the next block. And like right there, we haven't still figured this out because you actually have you have an arbitrage opportunity because you have two blocks in two different states.
And when the transaction final.
Right, and we're not sure about that, so we have to ask.
That's why I asked about shard,
Yeah.
because maybe you don't have to use cross sharding.
Yeah,
Cross shard transaction.
yeah, that would be great, but I think it's just random.
Yeah, thanks.
Thank you for listening.
Thank you.